Good morning, students. Jai Swaminarayan. Exercise 8.2, we were left with sum number 11. Okay. The question is that we are given two expansions, 1 plus x to the power 2n and 1 plus x to the power 2n minus 1. In both the expansion, the ratio of coefficient of x raised to n we have to prove as 2. So what the sum is, in this expansion, the coefficient of x raised to n, and in this expansion, the coefficient of x raised to n bears a ratio 2. Or coefficient of x raised to n in the first expansion is twice the coefficient of x raised to n in the second expansion. So if I operate general term, then students we get tr plus 1 is equal to 2n cr 1 raised to 2n minus r x raised to r. So this is result 1. And in this expansion, the general term is tr plus 1 is equal to 2n minus 1 cr 1 raised to 2n minus 1 minus r x raised to. Now for coefficient of x raised to n, in both the equations, students, I need to substitute r is equal to n. So substituting r is equal to n in equation 1 and 2. To get, students, coefficient of x raised to n, I need to substitute r is equal to n in equation 1 and 2. So we get tn plus 1 is equal to 2n cn 1 raised to n power is 1. So x raised to n, and tn plus 1 is equal to 2n minus 1 cn. Again this will be n minus 1. 1 raised to n power is 1. Now what does the sum say, students? We have to prove 2n cn upon 2n minus 1 cn is equal to 2. Or alternatively I can say that 2n cn is twice 2n minus 1 cn. So let us start with the left hand side, which is 2n cn upon 2n minus 1 cn. So this is 2n factorial upon n factorial into n factorial. This will be 2n minus 1 factorial into n factorial into 2n minus 1 minus n, so n minus 1 factorial. So there n factorial gets cancelled, reduce 2n by 1. So 2n minus 1 factorial, keeping n minus 1 factorial as it is. This is n into n minus 1 factorial. This is 2n minus 1 factorial. All factorial terms gets cancelled, n and n gets cancelled. So the ratio is 2. And that is equal to RHS. So students, in short, what we have to prove that coefficient of x raised to n in the first expansion is twice the coefficient of x raised to n in the second expansion. Okay students, now we have completed the lesson, so now we are starting miscellaneous exercise 8 and doing, students, first three sums. Miscellaneous exercise 8, and students, we are starting with first three sums. These three sums are going to be very important as these are long sums in subjective concepts. Now students, in the first sum, we are going to solve an equations, a set of equations which are not linear. Now what is the sum? In the expansion of a plus b to the power n, the first three terms are given, then find the values of a, b and n. So the first sum of miscellaneous exercise 8, expansion of a plus b to the power n, nc0 a raised to n e raised to 0, nc1 a raised to n minus 1 e raised to 1 plus nc2 a raised to n minus 2b square up to the last term NCN a raised to 0 b raised to. Students, this is the general expansion of a plus b to the power n. Now first three terms is t1, t2, t3 are given. So the first term is t1 and nc0 is 1. So this is related a raised to n, and that is 729 equation 1. Second term nc1 is n a raised to n minus 1b. This is 7290, result 2. And the third term nc2 is, students, n into n minus 1 by 2 I have simplified, a raised to n minus 2b square, and this is 30,375. So this is our result number 3, students. Now, what is the concept? That these three are equations, and we have to find three unknowns, a, b, and n. Students, three equations and three unknowns easily solvable, but these aren't a linear equation. Students, you are in the habit of solving linear equations. These are non-linear equations. So such type of equations are solved using ratio. So taking the ratio of result 1 and 2, we get a raised to n upon n into a raised to n minus 1b is equal to 729 upon 790, and that is 1/10. A raised to n gets cancelled. A equals n taking the numerator. So a by b cross multiply this n. So this is n by 10. This is result 4. Remember, a raised to n upon a raised to n minus 1 is a raised to n minus 1. So that will be a raised to n gets cancelled. Now, taking the ratio of 2 and 3, we get n a raised to n minus 1b upon n into n minus 1 by 2 a raised to n minus 2b square, 7290 divided by 30,375. So this is bit odd calculation, but we don't worry, n gets cancelled 2. This will be a upon n minus 1 into b. Shift this power, n gets cancelled. Now this is written as 7290 and 10 is written as 5 into 2 upon 30,375. So this 2 and 2 I cancel. This denominator is multiplied in the numerator. Now cancel this by 5. 5 ones are 56075. Easily you can do. Now this is divisible by 9. 9 81s are, and this will be 675. Again divisible by 9. 9 75s are again divisible by 3. So this comes out to be 3 by 25. So we will have a by b is equal to 3 times n minus 1 by 25. So this is result 5. I have done this calculations beforehand, students, but I have shown that how this is going to be simplified, students. Now compare results 4 and 5. Comparing results results 4 and 5, we get n upon 10 is equal to 3 into n minus 1 by 25. 5 2s are 5 5s are. So 5n is equal to 6 times n minus 1. 5n is equal to 6n minus 6. So n is equal to 6. Now we want a and b. So substituting n is equal to 6 in result 1. So a raised to 6 is equal to 729, which is 3 raised to 6. So a is equal to 3. And from 4, we have 10 times a is equal to n times b. A is 3, so 30. N is 6, so 6b. So b is equal to 5. This is the easiest way to find b. So, our final answer students are A is 3, B is 6, A is 3, B is 5, and students N is 6. This is how students we solve and get the answer of A, B and N. A is 3, B is 5, and students N is 6. Now students, we are going to do sum number 2. So these are non-linear equations, but always that fundamental rule of mathematics students is the same. Number of unknowns must tally with the number of equations. Number of unknowns must tally students with the number of equations. But these equations are students non-linear equations. These equations are students non-linear equations. So this type of equations are usually solved by the method of ratio. This type of equation students are usually solved by the method of ratio. That much students we have to perfectly remember. Now students, the next question is comparatively easy. In the expansion of 3 plus ax raised to 9, the coefficients of x square and x cube are equal, then find the value of a. Okay, the expansion of 3 plus ax to the power 9. 3 plus ax to the power 9. So this expansion will be 9c0, 3 raised to 9, ax raised to 0, 9c1. Students, we are told that coefficients of x square and x cube are equal. Okay, 9c1, 3 raised to 8, ax raised to 1, 9c2, 3 raised to 7, ax square, plus 9c3, 3 raised to 6, ax cube, and onwards. I am not writing all 10 terms because those 10 terms are not required. Now, coefficient of x square is equal to coefficient of x cube. So, coefficient of x square will be 9c2, 3 raised to 7 a square, and coefficient of x cube will be 9c3, 3 raised to 6 a cube. Okay, 9c2, so 9 into 8 by 2, 3 raised to 6 and 3 raised to 6 gets cancelled, 1 3 remains, a square, and a square gets cancelled, so 1a remains, that's all. 9c3 will be 9 factorial upon 3 factorial into 6 factorial into 8. So 2 1s are 2, 4s are 36 into 3, and here 9, 8, 7 upon 6 into 8. 6 gets cancelled. 3 2s are 3 3s are 2 2s are 2 4s are. So 36 into 3 upon 12 into 7 is equal to 8. 12 ones are 12 3s are. So the answer of 8 is 9 by 7. This is comparatively very easy. Now students, the third sum is very interesting. A hot favorite topic of JEE means many times the same type of question is repeated in JEE means. You can say a hot favorite topic of JEE means we are given two expansions, 1 plus 2x raised to 6 and 1 minus x raised to 7. 1 plus 2x raised to 6 and 1 minus x raised to 7. In the product of these two expansions, we have to find out coefficient of x raised to 5. In the product of these two expansion, students, we have to find coefficient of x raised to 5. So if I find this, it will be 1 plus 61 2x raised to 1 plus 62 2x raised to 2 plus 63 2x cubed plus 64 2x raised to 4 plus 65 2x raised to 5 plus 66 2x raised to 6. So this is result 1. Here alternate term plus minus 7c1x plus 7c2x squared plus 7c3 minus 7c3 x cubed plus 7c4 x raised to 4 minus 7c5 x raised to 5 plus 7c6 x raised to 6 minus 7c7 x raised to 7. Now, if I go by formal multiplication, students, pay attention. If I go by formal multiplication, first expansion has 7 terms and second expansion has 8 terms. If I am going to multiply 7 terms and 8 terms, then 7 8s are 56 terms I am going to get, and that becomes very big. So the master stroke of the sum starts now. Coefficient of x raised to 5 in product 1 plus 2x raised to 6 into 1 minus x raised to 7 is equal to. Now which term of first expansion I should multiply with second expansion to get x raised to 5? That is all. So when I multiply 1 with this term, I am going to get x raised to 5. Observe very carefully. In that, what is coefficient of x raised to 5? Minus 7c5 and 1. So 1 into minus of 7c5 plus. Now here x term and x raised to 4 term. These two terms if I multiply, I will get x raised to 5. What is the coefficient? Be careful. 7c4, 61 is 6 and this 2 is counted. 6 into 2, 12. Plus, I multiply square term and cube term, I will get x raised to 5. 62, 2 square is 4. And minus 7c3. Plus, I multiply this cube term and I multiply this square term. I will get x raised to 5. 2 cube is 8 into 6c3 into 7c2 plus this 4x to the power 4 and x to the power 1. These two terms, if I multiply, I will get x raised to 5. 2 raised to 4 is 16 into 6c4 minus 7c1 plus this last term x raised to 5 and 1. So 6c5, 2 raised to 5 is 32 into 1. Now, coefficients of 6 in Pascal triangle and coefficients of 7, 6 is 1, 6 is 0 is 1, 6, 15, 20, 15, 6 and 1, 1, 7, 7c2 will be 21, 35, 21 is 71. This you can easily use your Pascal triangle to get binomial coefficients for students 6 and 7. Now, 1 into minus of 7c5, 7c0, 1, 2, 3, 4 and 5. So this is minus 21 plus. Now 7c4, 35 into 12, 35 into 12, 6c2, 6c1, 6c2. This is 6c2 so 15, 15 4s are 16 into 7c3 is 35, so minus 35 plus 8, 6c3 is 20, 7c2 is 21 plus 16 into 7c1 is 7, 6c4 is 7, 6c2 so 15 plus 6c5 is 6 into 32, 75. Your answer comes out to be 171. So students, this arrows which I have shown is of lot of significance, based on which you will understand. Otherwise, if I multiply result 1 and result 2 and write 56 terms and then find coefficient of x raised to 5, this becomes very big. So the arrow diagram which I have shown students, that will help you to perfectly understand the sum. So, which term of first expansion must be multiplied with the second expansion term to get x raised to 5? This is the logic. So the arrows which I have shown, the perfect spacing which I have written between the two expansions will give you an idea, students, how this is obtained. Final answer is 171. Using your simple calculator, you can verify. Pascal triangle will give you the coefficients for power 6 and for power 7. So that I have written directly. By this time, all of you are well versed in that. Now, students, we are doing sum number 4. Now, students, we are doing the fourth sum. That is also very interesting, students. Okay, now students, please pay attention. If A and B are different integers, then prove that A raised to n minus B raised to n has one factor as a minus b, where n is a positive integer. Of course, A raised to n minus B raised to n has a factor A minus B, which is divisible by A minus b. That, students, we have to prove. Students, what we have to prove? That it is divisible by a minus b. Now the most important step of the sum is this, that a raised to n is written as a minus b plus b raised to n. This step is the master stroke of entire sum, and that is given as hint also. But in examination, students, we will not be given any hint. So that, students, we have to understand on our own. Now this term I consider as capital A, and I go with formal expansion. So this will be MC0, A minus B raised to n, B raised to 0. This is considered as only one term. Instead of writing a raised to n, we are writing a minus b raised to n. Then MC1, a minus b raised to n minus 1 b raised to 1. MC2, a minus b raised to n minus 2 b square, up to the last term in the term before that I am writing MCN, a minus b raised to 0 b raised to 1. A previous term will be MC n minus 1, a minus b raised to 1 and b raised to n minus 1. A term before the last term, right? And that will help us to understand the question very easily, students. This will help us to understand the sum very easily and perfectly, students. Now, this is simplified and written as a minus b raised to n. Let us write this as n b, a minus b raised to n minus 1. Remaining coefficients will not simplify. MC2, a minus b raised to n minus 2 b square up to. This is as it is MC n minus 1, a minus b raised to 1. B raised to n minus 1, this is 1 over b raised to n. There is easy simplification for last term. 1 into b raised to n will be net b raised to n. Students, now b raised to n I am transferring from the left. Already we have a raised to n. Therefore, a raised to n minus b raised to n is equal to a minus b raised to n, bn, a minus b raised to n minus 1 plus mc2, a minus b raised to n minus 2b square up to mcn minus 1, a minus b raised to 1, b raised to n minus 1. Now, this is the master stroke. Observe a minus b, observe a minus b, observe a minus b. Minimum power 1 is common. So if I am taking a minus b common throughout, from n, if I remove 1 power, it will be n minus 1. From n minus 1, if I remove 1 power, it will be n minus 2. From n minus 2, if I remove 1 power, it would be n minus 3. And last would be n minus 1, b raised to n minus 1. This step also must be very carefully observed. I have underlined all a minus b terms. The minimum power is always taken common. Students, as far as common is considered, we have to always take minimum power as common. Now, the bracket, I am supposing that the simplification of this bracket is n. This is an answer which is n. So this is a minus b into n. and this is divisible by a minus b. Or if I write a raised to n minus b raised to n has a factor which is a minus b, that is 1 and the same. That entire bracket which I have underlined, I am supposing that the value of that bracket is m. We are just supposing that value as n, and this comes out to be a minus b into n. So the value or the term a raised to n minus b raised to n has a factor a minus b, or it is divisible by a minus b. It is 1 and the same. So these four sums are a master stroke, students, for this particular chapter. And once you understand that, students, I don't think that you should have any problem for that. So students, this is a master stroke for the entire chapter, and once you understand this, students, I don't think that you should have any problem. Okay, here we conclude the remaining sums.